In this section, we will learn about how to prepare solutions, and we will learn how to determine the concentration of a solution as well as other related calculations. The picture on the right shows solutions with increasing concentration of blue colored solute uh, in the same volume of solution. The light colored solution contains less solute and the dark color solutions contains more solute. They're all made up of same solute, same solvent, only difference is the quantity of solutes. So the solutions which contain a very little amount of solute are known as dilute solutions. So dilute solutions contains less solute. And the solutions which contain high quantity of solute are known as concentrated solutions. So the examples of concentrated solutions are shown on the right side. Reporting the concentration of a solute in a solution is done routinely in any chemistry laboratory. The concentration of a solute is a quantitative measure of the amount of a solute in a given volume or mass of total solution. Thus, concentration is just a ratio. So therefore, we can say that concentration is a ratio where the numerator represents the total amount of the solute and the denominator represents the either the volume of solution or the mass of solution. So therefore, if we want to determine the concentration of a solute, we take the uh, amount of the solute, which would be its mass, and we divide it with the volume of solution, and this ratio will tell us the concentration of solute. So how do we prepare a solution? So we take a specific amount of solute. For example, this white powder is our solute, and then we add this solute in a fixed volume container. So all the solute is in the container, and then we fill the container up to a marked level. So this level may be depending on how big the container is, it could be 100 milliliter or 1000 milliliter. So all this mark tells us is that how much is the total volume of solution, and then we mix it or stir it to get a clear solution. So now if we want to calculate the concentration, we will take the mass of this solute, which can be measured before we dissolve. This mass will be in grams, and then we divide with the volume of this solution. For example, if this volume is 100 ml, so we will divide that quantity by 100 ml. So this ratio will give us the concentration of the solute. Mathematical problems, the concentration value can be used as a conversion factor which relates the uh, quantity or amount of solute to the volume of solution. For example, in this problem, we have a blood sample which has a iron concentration of 122 milligram per deciliter. So concentration of iron is given to us, and the concentration of iron is 122 milligram per deciliter. So what it means is that for every 1 deciliter it contains 122 milligrams. Remember, deci is a prefix, and 1 deci is equals to 10 to the negative 1. So we can use this to convert deciliters to liter if we want to, but this problem does not ask any specific units of volume, so therefore we will keep it in deciliters. So that is our conversion factor, and we obtained this conversion factor from the concentration. So because concentration states 1 milligram per deciliter, it means 1 deciliter will contain 122 milligrams of iron. What else is given? the amount of solute is given. So amount of solute, remember solute in this case is iron, and the quantity of solute is 28 milligrams, and we want to find what volume. So we want to find volume of solution. So in other words, we want to go from the amount of solute to the volume of solution, and we need a conversion factor which relates the amount of solute to volume, and that relationship is given here. So if we plug in the value, so amount of solute is given to us is 28 milligrams multiplied by conversion factor. So conversion factor gonna come from this relationship. So we know that 1 deciliter is 122 milligrams. So therefore milligram is gonna be in the denominator, 122 milligram, and 1 deciliter up here. So milligram will cancel with milligrams, and if we solve this problem, then we will get it will be 28 times 1 divided by 122 deciliters, or let me use my calculator, and the answer comes out to be 0.229 deciliters, because the smaller value is only 2 sig figs, so answer will be 0.23 deciliters. If needed, this deciliter can be converted into liters, but the problem does not ask us any specific unit, so we will keep it in deciliters. Since concentration is a ratio, the units of concentration are also a ratio. A variety of units are used to represent the amount of solute and the total volume of solution. The units of concentration most commonly encountered in medical field are given here. So these units are mass over volume percent. In this calculation, we take the mass of the solute and we divided by the volume of solution in milliliters, and then we multiply by 100. So that quantity is the mass over volume percent. For example, the normal saline concentration is 0.90%, which means it is mass over volume percent. For extremely dilute solution, we use parts per million and parts per billion units. So how do we calculate parts per million? So we take the grams of solute and then we divide by the milliliters of solution and we multiply it by a million. So it gives us parts per million of any solute. And in order to calculate parts per billion of any solute, we take the quantity or the grams of solute, we divide by milliliters of solution, and we multiply by 1 billion. And this calculation gave us parts per billion of solute. Remember, ppm stands for parts per million and ppb stands for parts per billion. These two units are used only to describe extremely dilute solutions. Let's calculate the concentration of the same solute in different units, which we learned in previous slide. So we will calculate the concentration of lead in drinking water in terms of grams per milliliter, which is the simple ratio. And then we will calculate the percent mass over volume, and then we will calculate in parts per million. Okay, so let's see what is given to us. The EPA, maximum allowable concentration of lead in drinking water, is 5 parts per billion. So given is concentration is given to us 5 parts per billion, and we want to find the concentration in grams per milliliter, and we need to find the concentration in percent mass over volume, and finally we want to find the concentration in parts per million. So we have three different calculations of the same solution. So now what's the meaning of concentration 5 parts per billion? So the meaning is that in this solution there are 5 parts or 5 grams in 1 billion milliliters of solution. That's the meaning of 5 parts per billion or ppb. Okay, so that means we kind of know the quantity or amount of solute. Okay, so let me write on the side. So amount of solute is 5 grams. How do we get 5 grams? Because that's the meaning of 5 ppb. The meaning is 5 grams in 1 billion ml of solution. So that's the meaning of parts per billion, 5 parts for every 1 billion parts of solution. And these parts are measured in grams and milliliter. And similarly, we know the amount of solute. Do we know the volume of solution? Yes, so volume of solution will be equals to 1 billion ml. So 1 billion ml is 10 to the 9 milliliters. So that's 1 billion. So now we are armed with this information. Let's calculate the other concentration. So first let's find the grams over ml. So in order to find the grams over ml, so grams over ml is equals to amount of solute in grams, of course, divided by the volume of solution. As simple. And from the information given in right, so the amount of solute is 5 grams and the volume of solution is 10 to the 9 ml. And if I solve this, so the answer will come out to be 5 times 10 to the negative 9 grams over ml. That is the ratio in grams over milliliter. Let's calculate now the percent mass over volume. So for percent mass over volume, we need the amount of solute in grams divided by the volume of solution in milliliters and multiplied by 100. That will give us the percent mass over volume. So again, the mass of solute is 5 grams and the volume is 10 to the 9 ml multiplied by 100, and this will give us a value of 5 times 10 to the negative 7% mass over V. And finally, the parts per million. So ppm is calculated by, let me change the color. So ppm is equals to the amount of solute divided by the volume of solution multiplied by a million, which is 10 to the 6. So ppm will be amount of solute is 5 divided by volume is 10 to the 9 multiplied by 10 to the 6. So this will be 5 times 10 to the negative 3 ppm. So that's how we can calculate concentration in any of these different units. Another common unit of concentration is molar concentration. It is abbreviated as M, and it is also known as molarity. The molar concentration of a solution is defined as the number of moles of a solute per liter of solution. So if we want to calculate molarity of any solution, we find the moles of solute and we divide those moles by the liters of solution, and we get the molarity of that solution. Molar concentration is the preferred unit of concentration in chemistry because the amount of solute is expressed in moles. And moles is a unit that indicates the number of solute particles, which may be atoms, molecules, or formula units per liter of a solution. Dilute solutions use millimolar concentration, where remember milli is a prefix and it stands for 10 to the negative 3. If a solute is given in grams, so first thing we need to do is to convert the grams of solute to moles of solute, and then divide moles with the liters of solution, and this will give us the molarity. Many times the solute will be given in grams, so in that case we have to find the moles from the grams, and we already know how to convert grams to moles. Let's take a look at a few examples. In this example, we need to calculate the molar concentration of carbon dioxide, in which 0.018 moles of carbon dioxide are dissolved to make 1.5 liters of solution. So given is the number of moles, 0.018 moles. These are given to us. Also, the volume is of solution is given, 1.5 liters. We must make sure that the units are liters. If it's in milliliters, then first thing we need to do is convert milliliters to liters. Fortunately, in this problem, units are already given in liters. And remember, molar concentration is equals to number of moles divided by the liters of solution. Okay, so in our case, number of moles are already given is 0.018 moles, and liters are also given 1.5 liters. So if we calculate this, the answer comes out to be 0.012 moles per liter. So this is the molar concentration of this solution. We can also use M as a unit, uppercase M. M means moles per liter. Either you can write moles over liter or you may write M. M means moles per liter. So either way, it is the correct unit. Many medicines are available in solution form. The concentration of these medicines represent the amount of medicine in a given volume of solution. In this section, we will describe common dosage calculations involving these solutions. Dimensional analysis is used and concentration serves as a conversion factor. Many medicines are given by mouth. These are called oral medications. These medications are often administered in solution or suspension form. For example, in this problem, an order is given for 60 milligram of Tylenol to be administered to a patient every 4 hours. The pharmacy supplied Tylenol as a 40 milligram per ml solution. How much Tylenol solution should be administered every 4 hours? So in this case, a patient is prescribed to take 60 milligram of Tylenol, but the pharmacy has only solution form of Tylenol. So now we need to figure out how many ml of this solution will be equal to 60 milligrams of Tylenol. So given is the mass of Tylenol needed 60 milligrams. So this much Tylenol is needed every 4 hours. And concentration of Tylenol solution is also given is 40 milligram per ml. So we can use concentration as a conversion factor. So from the concentration we can say that 1 ml Tylenol is equals to 40 milligrams. So this is the conversion factor which can be written from the concentration. So now we need to find the volume of solution of this Tylenol. So in other words, we need to convert mass to volume, and we can use concentration as a conversion factor, and that conversion factor will come from this relationship. So how much mass is needed or given is 60 milligram multiplied by conversion factor would be 40 milligram down here, 1 ml up here. So milligram and milligram cancel. So this will come out to be 60 divided by 40 ml, or 1.5 ml. So in other words, the patient would need to be given 1.5 milliliter of this solution every 4 hours. Some medications are administered intravenously. So these medications are known as IV medications. Intravenous administration of a medication directly into a vein is often used to deliver a pharmaceutical over a period of time. This method is necessary when the medicine is unstable or when oral administration is not possible, as in case of unconscious patient. To administer a medicine by IV, the solution is infused into the vein at a specific volume per unit of time. This is known as flow rate. Flow rate is defined by solution volume per unit time. In this case, doctors order a rate of medicines over a period of time. A rate refers to a ratio where time is in the denominator, such as miles per hour or milliliters per minute, which is the flow rate. So in this case also, the rate of medicine prescribed is equal to the solution mass per unit time. The rate of a medicine should be administered is usually given in units of grams per hour or milligrams per minute. Rates are conversion factors, and therefore they can be used as is or in their inverted form. For example, multiplying concentration as shown here. So this is the concentration. So multiplying concentration by flow rate, this section is flow rate, we get the rate of medicine in prescribed. So therefore we can say concentration times flow rate is equals to rate medicine administered. So this is one of the important formula which can be used to calculate the rate of medicine administered by multiplying the concentration with the flow rate. Similarly, inverted concentration multiplied by the rate medicine administered will give us the flow rate. These two formulas are frequently used in many flow rate and IV solution calculations. Let's take a look at a problem in which we will use the flow rate and concentration to calculate the rate of medicine administered. In this problem, a patient is receiving 30 ml per hour of an 8.0 microgram per ml solution of Isperel in D5W. So we don't have to really know what they are. These are medical terms, some name of some medication. So we don't need to worry about what is this medication. What we need to calculate is how many micrograms per hour is the patient receiving. So micrograms per hour, so that is the rate of medicine administered. This we need to calculate. What is given to us, flow rate is given to us. So flow rate is 3.0 ml per hour, or inverted flow rate will be this. Now 1 hour divided by 3.0 ml, that's the inverted or upside down. Similarly, concentration is also given 8.0 micrograms per ml, or inverted concentration is here. We know that concentration multiplied by flow rate is equal to the rate of medicine administered. So that's what we need to calculate. So therefore, by plugging in the values, we can calculate the rate of medicine administered. So that rate of medicine administered is equal to concentration time flow rate. So concentration is 8.0 micrograms over 1 ml multiplied by the flow rate. So flow rate is 3.0 milliliter per 1 hour. So milliliter cancels with milliliter and we get 8.0 micrograms multiplied by 3.0 divided by 1 times 1 hour, or 24 micrograms per hour. So this would be the rate, or micrograms per hour. So that's what we needed to calculate. So 24 micrograms per hour is the answer. Let's take a look at another problem. Droperidol is used to treat post-operative nausea. An order is given to administer 0.275 milligram over 3.0 hours by IV. So this gives us the rate of medicine administered. And we know rate is the equals to the quantity of medicine per unit time. So 0.27 milligram divided by 3.0 hours. So that is our rate. The IV solution has a concentration of 2.5 milligram per ml. So concentration is also given. So these values are given to us. So concentration is equal to 2.7 milligrams per ml. What should you set the flow rate in milliliters per hour? So this is the unknown and that's what we want to find. So we want to find the flow rate. Earlier we saw that the formula of flow rate is, so flow rate is equal to inverted concentration multiplied by rate of medicine administered. So concentration is given. So now we need to find the inverted concentration. So inverted concentration is the reciprocal of concentration, or upside down. So 2.5 milligram per ml means for every 2.5 milligram is present in 1 ml. So there's always 1 here. So inverted concentration will be equals to 1 ml divided by 2.5 milligram. So let's plug in the value. So inverted concentration is 1 ml divided by 2.5 milligram multiplied by rate at which medicine is being administered is equal to 0.275 milligram per 3.0 hours. So now milligram cancels with milligram and we get flow rate to be equal to 1 ml multiplied by 0.275 divided by 2.5 multiplied by 3.0 hours. So this comes out to be 0.275 ml divided by 7.5 hours, and if we divide these two numbers we get 0.037 milliliters per hour. So that is the answer. So 0.037 milliliters per hour. Earlier in this chapter, we learned how to prepare solutions by adding a pure solute to the appropriate amount of solvent using a volumetric flask. A solution can also be prepared from a more concentrated solution by dilution. Preparing a solution by dilution is necessary when solutes are not readily available in their pure form but are available as stock solutions. The concentrations of stock solutions are always given. So from that non-concentrated stock solution with known concentration, we can prepare a dilute solution by adding appropriate amount of solvent. Solvent is usually water. To prepare a solution from more concentrated solution, use the dilution equation which is given here. If the concentration of stock solution is C1 and the V1 is the volume of stock solution needed and C2 is the concentration of the dilute solution which we want to prepare and V2 is the volume of dilute solution which we want to prepare. If the concentrations are given in moles per liter or molarity, then this equation changes to M1 times V1 equals to M2 times V2, where M1 and V1 are the molarity and volume of stock solution, and M2 and V2 are the molarity and volumes of the dilute solution which we need to prepare. I will demonstrate how to use these equations to calculate the concentration of a dilute solution with the help of an example. In this example, we want to prepare 100 ml of 1% aqueous mass over volume saline solution. We must keep in mind that this equation is only used to prepare dilute solution from concentrated. We cannot prepare concentrated from dilute. That is not possible. Okay, so in this case, given is the volume of the solution which we want to prepare. So we want to prepare 1% aqueous mass or volume saline solution. So that would be our dilute solution. So this would be the volume of dilute solution which we want to prepare equals 100 ml. That is what we want to prepare. And the concentration of dilute solution which we want to prepare is 1% mass over volume from a 10% aqueous mass over volume solution. So this is the concentration of stock solution. So more concentrated, right? So 10% is more concentrated. So therefore concentration of concentrated solution, which is also known as stock solution, is equals to 10%. So what we are trying to do here is we are trying to dilute 10% stock solution to prepare 1% dilute solution. what volume of stock solution should you add to a 100 ml volumetric flask? So we want to find is volume of stock solution. And remember, the formula is C1 times V1 equals C2 times V2, where ones are the stock solution and the two are dilute solution. So let's plug in the values. So we already know the value of C1, we already know the value of C2. So C2 would be the concentration of dilute solution. So this would be C2, this value would be C1, and this value would be V2. That's the volume of dilute solution. So let's rearrange this equation. So if we shuffle this equation to calculate the volume of stock solution, we get V1 is equals to C2 times V2 divided by C1. And let's plug in the values. So C2 is 1% and V2 is 100 ml, is 1% mass over volume. Let's keep the entire unit and divided by C1, and C1 is 10% mass over volume. So the unit percent mass over volume cancels with percent mass over volume. So the answer comes out to be V1 is equal to 100 ml divided by 10. So this equals to 10 ml. Okay. So it means the volume of stock solution which is needed to prepare dilute solution is 10 ml. So let me explain what does that mean. It means is that you take 10 ml stock solution and then you add water or the solvent so that the total volume becomes 100 ml. So now total volume is 100 ml, but we already took 10 ml of stock. So how much water we need? So it means that water needed is 90 ml. So 90 ml water and 10 ml stock solution. So together 90 plus 10. So that would be 100 ml total. So this would be the dilute. So because we added water, so the stock solution is diluted. So if we mix them in this proportion, the final dilute solution concentration would come out to be 1%. And that's how we calculate how much volume of stock solution is needed and how much water is needed to be which should be added to prepare any concentration which is a dilute solution.